In this video, we'll be talking about simplifying radicals. So let's start with this first problem, the square root of 12. Now, to simplify a radical really means that you look at the number under the radical and you try to get as much of that number out from under the radical symbol as possible. So, new day, new question. Let's actually try a simpler version of this, the square root of 25. Well, we all know the square root of 25 equals 5. So this is a simplified version of this problem because we've gotten the 5 out from under the radical. So that's really what we're trying to do here with the square root of 12. Now, the way that we do this is by looking for perfect squares that go into this number under the radical. So in the case of 12, a perfect square that goes into 12 is 4. So I can rewrite the number 12 as 4 times 3. And so really, if we look at the whole problem, the square root of 12 is the same thing as the square root of 4 times 3. They're equal. Now, here's an interesting property of radicals, that when you have two things under the radical that are multiplied together, you can break that apart into two separate radicals. So this only works with multiplication and division. So we can break this up into root 4 times root 3 as two separate things. Now from here, because we chose that perfect square 4, we know the square root of 4 is 2. So our final answer is 2 root 3. So you can see how we took part of that number 12 and we got it out from under the radical. And that's really our goal when we're simplifying radicals. Okay, so let's look at another one. We have 5 times root 99. So let's think, what would be a perfect square that goes into 99? Well, 9 goes into 99, and 9 is a perfect square. So 9 times 11 is 99, and we've also got this 5 out in front, so we'll keep writing that out in front there. So if I break this up into keep my color coding. Root 9 times root 11, the square root of 9 is 3. So now I have 5 times 3 root 11, and that 5 times 3 gives me 15. So anytime you have that number out in front, if you're able to break more numbers out of that radical, then you've just got all that stuff multiplied together. 5 times 3 gets us that 15. But again, it all comes down to simplifying that perfect square. That's why it's so important that we find the perfect square that goes into this number. Okay, so that brings me to this next problem, the square root of 504. Now, if you're like me, you're looking at a problem like this going, I don't know what perfect squares go into 504. That's a really big number. Is it 4? Is it 9? Is it 25? And here's where I think it's kind of helpful to have a list of all of our perfect squares written out. So I've been using this word a lot. A perfect square is really just a number that you get when you multiply the same thing times itself. So 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 is 16, and so on. You get the idea. Okay, so just to kind of show you the final answer here, the highest perfect square that goes into 504 is actually 36. So if we break down 504, we can break this down into 36 times 14. Now you might be thinking, where did that come from? How did you know? So I usually, with these kinds of problems, I pull out a calculator and I divide the number under the radical, 504, by every single perfect square and see if it divides into an integer. So for example, 504 divided by 4. Does that give me an answer? Well, let me just take out my calculator and see. 504 divided by 4, yeah, that equals 126. So that tells me that 4 is a perfect square that goes into 504. Now, I might have done So in doing this problem, I might have said, okay, my answer is 4 times 126. And that would be true, but it's not the most simplified answer. We already know the most simplified is going to be 36 times 14. So really what you're looking for here is the highest possible perfect square that goes into this number under the radical. So sure, 4 goes into 504, but it's not the highest one, and that's the key. So I might keep on going down the list and say, okay, well, what about 9? Does 9 go in? In fact, it does. 504 divided by 9 equals 56. So again, 9 goes in too, but I'm going to keep checking to see if there's any ones that are higher. What about 16? Does 16 go in? 504 divided by 16. I'm just checking to see, does 16 go into 504? In this case, I get 31.5. So because it's a decimal there, that tells me, nope, 16 doesn't go in. What about 25? I'm going to get a decimal there too. That's not going to work. Then we get up to 36. 504 divided by 36, that gives me the 14, and that's when, I mean, we could keep on testing. We could try the 49 and the 64 and the 81, but at this point, I know I found the highest perfect square that goes into 504. So that's why I'm using 36, and I got the 14 because that's the other number that multiplies by 36 to get 504. Okay, so now that we've got all that, now we're ready to simplify this problem by saying the square root of 36 times the square root of 14. This whole guy simplifies to a 6, and our answer is 6 root 14. So that's your process for finding the highest possible perfect square. All right, so now let's keep on going. I want to show you another little trick for solving. If this whole thing with the perfect squares is kind of confusing to you and you're not quite sure how to do it, let me show you another way of simplifying these radicals that might make things a little easier. So let's use that same example. We have 504. So we'll find the square root of 504. Now, the way we want to do this is basically we want to find all of the prime factors of 504. So I can do this. I'm just going to set up a little table here to organize. I'm just going to divide by prime numbers over and over again until I've divided as much as I can. So the smallest prime number is 2. So I'll divide 504 by 2. Well, that gives me 250, 252. All right, well, I can divide that by 2 again. So divide that by another 2, and I get 126. Well, I can divide that by 2 as well. So I'll divide by 2 again. That's going to give me 63. All right, so now I'm thinking, all right, what can I divide by 63? I can't divide it by 2, but maybe I could divide it by 3. All right, so I'll divide 63 by 3, and that gets me 21. Well, I can divide 21 by 3 again, right? And that's going to give me 7. I'll divide 7 by itself and get this all the way down to 1. And now I have all of the prime factors of 504. So here's what we do with this. This means that the square root of 504 is the same thing as the square root of 2 times 2 times 2 times 3 times 3 times 7. I'm just rewriting all of these numbers under the radical because all of these guys multiply to 504. So from here, I'm looking for pairs of numbers because if you think about it, 2 times 2 is 4, and hey, that's a perfect square, root 4. 3 times 3, hey, there's another pair of numbers. 3 times 3 is 9, so that's another perfect square. And then we've also got this extra 2. Now, the square root of, that one doesn't have a pair, so that one's not a perfect square. So we have root 4 times root 2 times root 9 times root 7. Well, the perfect squares are going to simplify. The square root of 4 is 2. The square root of 9 is 3. So boom, now we've gotten those numbers out from under the radical, and that's what we want to do when we're simplifying radicals. Now these other two, the root 2 and the root 7, those aren't going to simplify. Those can't come out from under the radical, so we'll just combine them back together. Root 2 times root 7 is root 14. So our final answer here will multiply. 2 times 3 is 6. So our final answer is 6 root 14. And you notice that's actually the same answer that we got up here when we used the other method. So whichever method works best for you is fine, and have fun simplifying those radicals. Finally, let's talk about cube roots, fourth roots, etc. You've got fifth roots, sixth roots, it can go on and on. So here we have the cube root of 24. So now, rather than looking for perfect squares that go into 24, now we're going to look for perfect cubes that go into 24. So some perfect cubes are 8, 27, 64. So 8 is a perfect cube because it's 2 cubed. 27 is a perfect cube because it's 3 cubed, and so on. So a perfect cube that goes into 24 is 8. So let's look and see, let's kind of break this apart into the cube root of 8 times the cube root of 3, right? Because 8 times 3 is 24. All right, so the cube root of 8 will simplify to 2, while the cube root of 3 isn't going to simplify at all. There is no number that you multiply 3 times and get 3, so this would be our final answer. Finally, for the fourth root of 81, well, our answer here is just going to be 3. And the reason why is because 3 times 3 times 3 times 3, well, that equals 81.